This is module 2.4, and for this discussion we'll be making a piecewise function, one for x is less than -2 and one for x is greater than or equal to -2, and we'll be defining the limits left, right, and combined. Using my name, I got an exponential function for my initial function and a rational function for my secondary function. Chose to express it as follows: 3 to the x plus 2 power plus 1 and x plus 1 over x plus 2. When you throw that in the Desmos, it looks like this. And here's our graph. Evaluating the limit from the left side, we can just plug in -2 into our equation and see what we get. 3 to the 0 power is 1, 1 plus 1 is 2, so we know our limit is 2. So you can see that it approaches 2 but never actually reaches it because we can't plug in the actual value of -2 for x. When evaluating the second function, we can just plug in that number again from the right side. -2 immediately gives us not a real number, so we know that it cannot exist. And using what we learned about unbounded behavior of functions, we can see here that because it never really approaches any single real number, it can't have a limit at -2. So our limit does not exist. And then for our two-side limit, we can go ahead and use the analytical function. We know that in order to have a limit, both sides of the equation need to be approaching the same point, of which they are not. We proved that here. One's approaching 2, one does not exist. So obviously our two-sided limit doesn't exist. We can prove that using our graph. We can clearly see that our right-sided function will continually approach -2 and never reach it, and our left-sided function ends right here, almost hitting 2 but never actually doing it.